Hello, McLeod. Is it McLeod or me? MECLADE. What's this? Okay, hello, grade. It's a grade 11th, right? But I suppose grade 10s could possibly be here, possibly, right? We could possibly have grade 10s here, and otherwise, how is everybody doing? How's everybody doing? I hope you guys are well. I hope you had a wonderful weekend. The weekend has been good so far. I am the guy who basically is behind the Maths is a Game live lessons. Maybe you may have, if you are joining in for the first time, you may have perchance come across live lessons such as this, and you may have seen a lesson or two go on, whether it be grade 8, 9, 10, 11, 12 mathematics. Yeah, I basically play around with maths because maths is such a sweet game to play. It's got a lot of rules, but yeah, it's playable. So basically today I'm here to start up a topic called functions. A topic called functions, all right? And hopefully through this topic and through doing it, we'll be able to sort of like see what is the do with functions as it pertains to the grade 10 syllabus, as it pertains to the grade 11 syllabus, because that's where the foundation is. In actual fact, grade 9 gets people kicked off with the functions, so we're just going to take a look at the functions as it relates to that, and we're going to take it one bit at a time. Okay, so yes, today, ladies and gents, we are going to be confronting this beautiful topic that we refer to as functions. And just off the bat, before we really delve into it, I just want to bring notice to those who are at school. So in grade 10, functions has a period of 4 weeks that it's dedicated. Like there's a period of 4 weeks that is dedicated to functions alone. Okay. 4 weeks. 4 weeks. So that's pretty much like 20 days if you want. 20 days is dedicated to functions. 20, right? 20 days. Then if you want to tackle it down to like the number of hours that is spent, then you can take it down to the number of hours that is spent. If your period is 55 minutes, then 20 days, you're going to times that by 55, and then you're going to sort of like get a rough idea as to how many hours is actually spent on functions. Okay. So that's for both grade 10 and 11. In grade 10, there's 4 weeks dedicated to functions. In grade 11, there's 4 weeks dedicated to functions. And furthermore, something to note is that in your exam paper for grade 11, functions has 45 marks that it's dedicated to just functions alone. 45, guys, 45 marks. Okay, so roughly, your grade, your grade 11 paper at the end of the year is 150 marks, and 45 marks plus minus is dedicated to functions. So this is a big portion of work that we need to be on top of. Okay, I want to also just bring to your attention that you've already done algebraic equations, inequalities, and you did basically paper 1 related topics in term 1 already. Your algebra, your equations, your inequalities are also dedicated the same amount of marks, 45 marks. So out of 150, 45 marks is dedicated to functions, and then another 45 marks is dedicated to algebra, equations, inequalities, nature of roots, and basically the topics that you covered in term 1. That's not including trigonometry. Trigonometry is excluded from this, but like 45 marks is dedicated to functions, and then 45 marks is dedicated to algebraic equations and inequalities. So please, people, as you delve into this topic, it becomes very important for you to make sure that these marks do not go missing somewhere. All right. So I just want to bring that to your attention so that as you guys do it and as we go through functions, you make it a point that you don't miss anything out, from functions. Okay. So I'm going to do a grade 10 recap first, because it would be futile if I just jumped into functions and I did it from a grade 11 stance. I would have to first do a grade 10 recap. We need to check if we can still remember what we did in grade 10. Okay. Now in grade 10, you guys looked at 4 types of functions. You first looked at what we refer to as a linear function, or usually they refer to it as a straight line graph, as they would call it. Okay, I hope we are all in the same page. Linear function or straight line graph. That was one of your functions. I just want to see if people still remember. Do you guys remember what was the general form of a linear function? Maybe someone in the comment section can help me out. What was the general form of a linear function? Okay, of course this function was done in grade 9 as well, but then in grade 10, you did it and extended it. Okay, so I see my man Innocent there says mx plus c. Okay, is that complete? Mx plus c. So you guys are saying the general form for a straight line function is mx plus c, and that's it. That's the general form of a straight line function. We all in agreement, right? Is that everybody saying yes, we agree, Innocent is 100% spot on? Okay, so let's just put in there that y, it's very important. Y is equal to mx plus c, because a function has a relationship between y and x. So basically we need to be a bit more complete when you write the form of the general form, or the standard form for a linear function is y is equal to mx plus c. Now, very importantly, people, this, like I said, is the general standard form. So if the function is written in any other way, all right, we need to make sure that we always get it to be in this form, so that we can be able to then read certain information from just the function itself. Now, I want to ask the following. What does the m stand for? What is the m? What does the m stand for? Do you remember what the m stands for our standard form? Okay, Wandile and Precious and Alice, very good. Gradient. We also refer to a gradient as the slope. All right, yeah. Now we want to look at the conditions of gradient. Gradient can be greater than 0. Gradient can be less than 0. Gradient can be equal to 0. And gradient can be undefined. Please take note. Gradient can be greater than 0. In other words, what do we mean by this? It can be positive or it can be negative. And obviously, if we're saying equal to 0, it just means equal to 0, or gradient can be undefined. Now, this gradient affects the shape of our straight line function. Maybe you're going to ask, how so? So if the gradient is positive, my beautiful people, we should experience a straight line function that we say is increasing. In other words, as x increases, right, that is from left to right, y also increases from top to bottom. Okay, so as x increases from left to right, y also increases from bottom to the top. Okay, and this is very, very important. That's why we say the gradient of the straight line, when it is positive, we then experience what we refer to as a shape that is an increasing function. Okay, hope you understand that. Okay, so we say this is a increasing function. And in actual fact, that means that the function increases everywhere. There's no place where this function does not increase. It increases everywhere. All right. 2. If the gradient is negative, less than 0, then we say that the shape of the function, or the straight line in this case, is decreasing. In other words, as x increases, what happens to y? Y decreases. So we call this a decreasing function. Okay. All right, so that's when the gradient is negative. What about when m is equal to 0? When m is equal to 0, then we have a straight line that is simply horizontal. We have a horizontal straight line. Horizontal straight line. In other words, there is no increase, there is no decrease as far as the gradient. Okay, so when m is equal to 0, we have a constant function, it's horizontal. That's when the gradient is equal to 0, a horizontal straight line. So I'm going to say a horizontal function. That's when m is equal to 0. Okay. Then last but not least, the fourth part, or the fourth thing about when the gradient and its condition. When m is undefined, when the gradient is undefined, we say that the straight line is vertical. Okay, vertical. Okay, we have a vertical function. And now something very unique, guys, about when m is undefined. So if you look at the form, the standard form of a straight line function, we said it's y is equal to mx plus c. That means when m is positive, then obviously this gradient here will be positive. When m is negative, then it means that the value of m here will be negative. When m is equal to 0, it simply means that this x will disappear. Y will be equal to just a constant value. All right, which makes sense, because if we have a horizontal line, that simply means that the y is equal to that value, okay, of c, all right, throughout. Okay, and then when m is undefined, very uniquely, and this is very, very unique about when m is undefined, that's when x is equal to some constant value. All right, so the equation of the straight line function where m is undefined, where the gradient is undefined, is simply x is equal to c, some constant value. All right, whereas when m is equal to 0, y is equal to c, some constant value. So when m is equal to 0, y is equal to c. Okay, whatever that constant value is, if it's positive 3, then obviously it's y is equal to 3. If it's negative 3, then it's y is equal to negative 3. Whatever that value of c is. Okay, we'll look at some examples, but it's just important for us to understand what m is and what m stands for. So m is the gradient. What does it do? It affects the shape of the straight line function. If m is positive, we have an increasing function. If m is negative, we have a decreasing function. If m is undefined, we have a horizontal line. And if m is undefined, if m is equal to 0, we have a horizontal line. And when m is undefined, we have a vertical line, right? And that's very important to note. So that's something I want us to start off from the get-go. What does M stand for? Now the thing is, M also, besides tell us about the gradient and the fact that we know what effect it has on the function, in that it affects the shape. Yeah, I think that one we can grasp that one. Can I screenshot your notes? Please go ahead. There we are. And I'm just zooming out a little bit here so that you can screenshot the notes if you want to. Okay. So that's just 1, 2, 3, 4. I was just talking about M because someone, as I asked in the beginning, I asked what is the general form of a linear function. Someone said to me, it's y is equal to mx plus c. Remember, the M and the c, they basically stand for any what? The M and the C are basically any real value. Any real value. They can be any real value. All right. And remember, real numbers means any rational or irrational number. M and C can be any real number. You'll find that in other textbooks, they'll use A and Q. All right, guys, that's not of importance. As long as you understand that the coefficient of X stands for the gradient. All right. Okay, so, and then this is the situation. If M is positive, then we can expect an increasing function. M is negative, this is the function. If M is equal to 0, a horizontal line can be seen. That's when y is equal to some value. And then when M is undefined, okay, then you have a vertical line, okay, so that's very important. Now let me move on very swiftly. Let's go and look at, we've looked at M, now we need to look at C. What does C stand for? Anyone know? When we talk about C, what do we identify it as for our function? Okay, yes, it is a constant, and pressures is very spot on with mult. Okay, yeah, so specifically C, yes, C is a constant value, you are right. Okay, but this constant value represents what in our function? It represents the y-intercept. Now let me not take for granted and think that you guys know I have been I've been uploading on YouTube. Maybe you're not getting notifications, I don't know why. Okay, so C is the constant value, but the thing is I haven't done lives in a very long time. C or CQ, don't worry, that's the thing. Okay, so C is the constant value. It represents the y-intercept. What is a y-intercept? Basically, a y-intercept is where the function cuts the y-axis, where the function cuts the y-axis. Okay, yeah, remember that there's something called a Cartesian plane. It has the y and the x-axis, and simply what the y and the x-axis are is a number line in the horizontal plane and then a number line in the vertical plane. So we have 0, the origin. We usually refer to this as the origin. Okay, then this side you have all the positive numbers, and this side you have all the negative numbers for x. Then here you have the negative numbers for y, you have the positive numbers for y. So that's why we say above this x-axis, we say that the values of y are positive. Below this x-axis, we say the values of y are negative, all right? And then, like I said, x and y. So if we're saying C is some constant value and it represents the y-intercept, where the function cuts this y-axis, that's where our C, that's what our C value will be, all right? Where the function, the straight line function, cuts the y-axis. So for instance, let's say there's a straight line that cuts at 2. Then rest assured that because this straight line, which has a positive gradient, by the way, because it cuts at 2, then you can expect and anticipate that the value of c, all right, for that particular straight line will be 2. Okay, so c is a constant value that represents the y-intercept. What is the y-intercept? The y-intercept is where the function cuts the y-axis. Okay, all right. I think so far we should be okay. We are good. So now we understand what c is. All right. So if c is a positive value, then it means that the straight line function cuts the y-axis at positive above the x-axis. But if the c value is negative, then obviously it means that the function cuts the y-axis at the negative part of the y-axis. So it cuts the function below the x-axis, and that's very important. So that's what c stands for. So I hope, guys, we can now sort of like see that, okay, if ever I'm given a straight line function, y is equal to mx plus c represents a linear function. How do we become convinced that it is linear indeed? It's because the linear function, when it's in its standard form, has a coefficient, all right, which represents the gradient. It has x, which basically is a variable, all right, and that variable obviously has the exponent 1. Okay, this speaks to the fact that we say it's linear. Linear expression means that the x variable is raised to the power 1. Okay, so that is why we say it's linear. Okay, so the variable x in the numerator is raised to the power 1. The x in the numerator is raised to the power 1, and then plus the constant value. That is our straight line function. That is the form that we know our straight line function should be in. Okay, so let's look at this, guys. Just an example. If I have this here as my function, y is equal to 2x plus 1. I have a question for you. I want to ask you first and foremost, what is the gradient of the function? Maybe you can answer me that question. What is the gradient of the function? Okay, so Rialeboga, Boitumelo Presh, Cecihle, Luandle, Enueli. Yeah, you guys are spot on. So yes, the gradient of the function is 2. You guys are spot on. Then I'm so happy. I'm happy. Seems like we are doing very well. I'm asking the very same question. Yeah. On what condition can we say that x is equal to c, precious? On the condition that the gradient is undefined. That is the condition where we say x is equal to c. All right. If the gradient is undefined, we say x is equal to c. Secondly, if we have a vertical straight line function, then obviously that vertical straight line function will have the equation x is equal to whatever the constant value is where this straight line cuts the x-axis. It will be equal to that value of x. Okay, we'll look at some examples. Just for now, guys, I just want to check this MNC, that you guys understand this MNC. We'll get into other examples so that we can see that, okay? So I was asking, y is equal to 2x plus 1. What is the gradient? You guys said m is equal to 2. You guys are 100%. I love you. You guys are amazing. You are phenomenal. I even give you a red pen there. Okay, same question. 2x is equal to y minus 3. Now I'm asking this question. What is the gradient of the function? 2x is equal to y minus 3. What is the gradient of the function? Okay, hello. Okay, they're saying still 2. People are saying it's still 2. Menier, it's still 2. All right. But in order for us to really establish that, what are we going to first do? We are going to first take this equation and write it in standard form. Okay, so we can see that the x is raised to the power 1, so that means that this is a linear function. But now we need to first write it in standard form. So 2x is there. Let's transpose the minus 3 because we see the y is already positive. Make y the subject of the formula minus 3, we transpose it, it becomes x, 2x plus 3 is equal to y. So the y is isolated, y is equal to 2x plus 3. So we can say therefore y is equal to 2x plus 3. So you guys said m is equal to 2. You guys are 100% spot on. I agree with you. Why? Because when my equation is in standard form, that is where I can begin to speak or say anything about the function's gradient. Okay, so y is equal to 2x plus 3. So what I did is I transposed the minus 3. It became positive 3 on the left-hand side. The y is positive already. It's isolated. So I've made it the subject. Then I concluded, therefore, the y that was isolated is equal to what? 2x plus 3. So the gradient truly is 2. Thank you so much. You guys are amazing. Okay, so I would once again just give you a nice tick for those people that said m is equal to 2. I know some people said m is equal to -2, but yeah, we need to be very careful. Are you with me, my good people? Let's write this one. Y minus plus 2x is equal to 7. I'm asking again, what is the gradient of the function, of this straight line function? What is the gradient? Okay, Oitumelo says -2. Navigator as well. MOLT says so as well. Pressure says so too. Yes, so you guys, all right. Okay, those who are saying -2, let's check. Let's first get the function in its standard form. Y is equal to, isolate y, transpose the 2x over to the other side. It becomes -2x plus 7. Is this in standard form? Yes, it is. Is it in this form? Yes, it is. So therefore, y is equal to -2x plus c. The gradient is truly equal to -2. Okay, so you guys are spot on. So once again, to those people who said -2, you guys, how amazing you are. Okay, I'm gonna do one last one. Okay, once again, 3y minus 3x is equal to -9, sorry. So once again, what we want to do here is we want to find the value of the gradient. Okay. Titebucho says 3. Boydumelo says 3. Longle says 3. Okay. And I love the fact that when people, as you type, there should be some sobriety that comes to your head. As you type and you see other people's comments and you're like, okay, am I right? And if I am not, what could be causing me not to be right? And why are other people saying something else that's different from me? Okay. And then ultimately, if you have a pen and a paper before you, you will basically write it down as well so that you can be able to do what needs to be done. And then you will see what you need to see. Because when you do, then it's like aha moment. All right. So yes. All right. I think I have allowed at least some time, sufficient time to pass. So let's go ahead and let's go and get this into standard form. Let's isolate the y. 3y is equal to, we transpose the -3x, it becomes 3x minus 9 on the other side. Do we agree so far? Okay. Then what do we do? The coefficient of y is 3. When it's like that, what do we do, guys? We must divide by the coefficient, right? And then that gives us what? Y is equal to x minus 3. Are you with me? So therefore, the gradient. Who is there? Who is there but we don't see them in the mix? M is equal to the gradient of the straight line function is equal to 1. Please, my beautiful people, how important it is for you to be able to realize or see this. Because when you do, then how amazing it is when you do. All right, so please let's make sure that we are able to identify the gradient. All right, and this is just me, like I said, exploring the fact that we've established ourselves that the straight line function has this form, y is equal to mx plus c. So if it does, we know that m stands for gradient. All right, and we know that we can only read the gradient when the function, that straight line, is in this form. That's when we can read what the gradient is. If it's not in this form, we need to then first convert the function to be in the form first. Okay, this is not in the standard form, so we first get it into standard form, then we can identify the gradient. This is not in standard form, we first get it to be in that form, and then we read the gradient. This was definitely also not in the form that is the standard form for a straight line function. We get it into that form. And do you see what's happening here? We are applying our algebraic skills that we have learned in the previous grades so far. If those skills are not polished up, then we are going to take for granted the things that we ought to do in order for y to be isolated. All right. We are transposing, we are dividing by the coefficient for all three terms because this is an equation, and then we are able to identify what the gradient is. So big up to those people that saw that the gradient was 1 even from the get-go. All right, and please people, let's all get on board so that we do not fall short at identifying the gradient of a particular function. I hope that makes sense. Okay, and then if I was to go back to the very same question and I was to ask you, give me the y-intercept for this function, what would you say? If I said to you, what is the y-intercept for this function, what would you say? Y is equal to 2x plus 1. What is the y-intercept? Okay, all right. Please, people, and I hope all of you, all right, when you write your answer, if I asked you what is the y-intercept, then please go ahead and say to me, y is equal to 1. Please do say that to me. The y-intercept is y is equal to 1. It's like, for instance, if I come here as well, and I asked you for this particular function, this one, what is the y-intercept? For this one, y is equal to 2x plus 3. What is the y-intercept, my good people? Y is equal to 2x plus 3. The y-intercept is? The y-intercept is? Y is equal to 2x plus 3. The y-intercept is? Okay, thank you so much, guys. I can see that in the comment section, you guys are saying 3. All right, so yes, if I ask you what is the y-intercept, okay, then yes, for that one, y is equal to 3. Thank you very much. Okay, let's move on. What about this one? If I asked you what is the y-intercept for y is equal to negative 2x plus 7, what would be the y-intercept here? Okay, thank you so much, 7. Okay, then last but not least, since you guys are on a roll, what would you say is the y-intercept for this particular function? Okay, you guys get the point. Okay. Okay, now, hold it right there. I like what you guys are doing for me. I want to ask one last question. If I asked you what are the coordinates of the y-intercept, what would you say? What are the coordinates of the y-intercept? Let's go back here. What are the coordinates of the y-intercept? Okay, I love what Ditebucho is saying there. If you say y-inter is equal to 3, that's beautiful as well. Okay. If I asked you what are the coordinates of the y-intercept, what would you say, guys? Okay, because remember when I asked you what is the y-intercept, you guys said y is equal to 1, which was fine. But now I'm asking what are the coordinates of the y-intercept? for y is equal to 2x plus 1. This one, guys, we're looking at this one specifically. The coordinates for y is equal to 2x plus 1. Okay, I love what I'm seeing there in the comment section. A lot of people are like, you guys are so aware, hey? Okay, I hope you guys still remember that whenever you wanted the y-intercept, what did you do? For y-intercept, you let what? You let x be equal to 0. If you let x be equal to 0, it means then you are going to find the value of y. And the value of y that you get is y is equal to 1. All right? And basically, if I'm saying I want the coordinates, it means that the coordinates would be 0. Okay, because remember, when we say y-intercept, we are letting x be equal to 0. So x is 0, and then y is 1. Okay, so it's very different. When I ask the question and I say, what are the coordinates of the y-intercept? It means I want the x and the y-intercept, the x and the y value that are basically the point where the graph cuts the y-axis. Okay, so different question. The coordinates of the y-intercept for that one is definitely 0 and 1. Okay, let's move on to this one. Y is equal to 2x plus 3. What are the coordinates of the y-intercept here? What are the coordinates of the y-intercept? Okay, thank you so much, guys. Beautiful, beautiful. 0 and 3. I love it. Yes, 0 and 3. So let's not forget that when we say coordinates, we need to write coordinates. If they simply ask us what is the y-intercept, then we write y is equal to whatever value. Y is equal to whatever value. But if they ask what are the coordinates of the y-intercept, we write the coordinates. Okay? Okay, let's move on. This one, what are the coordinates of the y-intercept here? Y is equal to negative 2x plus 7. Coordinates of the y-intercept. Oh, here we go. Thank you, boy Tumelo. Coordinates of the y-intercept, beautiful. Hello, thank you. Nenweli, Nurain, you can't comment. I don't know why. Maybe did I restrict your commenting privileges there? No filter, Nje. I didn't put any filter for you. I've allowed all sorts for you. I don't know why you can't comment. I'm sorry about that. I'm sorry for those who are commenting. Nenweli, I'm sure you're commenting correctly, but just that you are being limited by TikTok. I'm very sorry about that. Oh, Ditebo, okay, that's fine, guys. So yes, it's 0 and 7. The coordinates of the y-intercept are 0 and 7. And then here, guys, the last one. Coordinates of the y-intercept here. Now I'm gonna see this last comment if people really are just amazing. If you guys are amazing, I'll see you by you commenting correctly here. What are the coordinates of the y-intercept here? Oh, Mbali, thank you so much. Hey, Mbali is always generous here. Thank you so much. I really appreciate it so very much, Wendy. Coordinates of the y-intercept here, guys. Coordinates of the y-intercept for y is equal to x minus 3. Navigator there coming in and answering first. Thank you so much. Okay, we are here now, Nenweli. I see you finally got the chance to comment, but I guess we're commenting now here. We are here. Okay. I'm sorry, Ditebo. I'm sorry that you guys can't comment. But yes, the coordinates here for the y-intercept are 0 and negative 3. Thank you so much. Thanks a ton. All right. Okay. Guys, I think we are kind of sorted, eh? So now we know for a fact that this standard form, general form, M really does stand for gradient. If the gradient is positive, we are expecting a function that is increasing like this. If the gradient is negative, we are expecting a function like this. If the gradient is 0, we're expecting a function that's horizontal. If the gradient is undefined, we're expecting a vertical, you know? Right, okay, nice. Now, Let us enter the world of sketching for a little while, even here for our straight line function. Okay. And guys, some of you may be like, hey, this guy is moving too slow for my liking. I am deliberately so, because remember, like I said, guys, this is a 4-week topic, right? And the 55 minutes is dedicated for you to learn something else, learn something else, learn something else. So what I'm going to do is I'm not going to do everything all at once. I'm also going to break it down, and I'm going to do sort of like one by one. And then at the end, like when we kind of like have finished the whole of functions, then we're going to do the mix where we have all the functions in one Cartesian plane, and we can look at interpretation. In fact, we are going to have a session at looking at interpretation alone, so that you guys can also be on board as to like how do we attempt and how do we identify the different interpretation type questions. Okay, functions are very easy, very nice and easy and sweet. And once you get the basics, guys, everything else should really take care of itself. So that 45 marks that is designated for functions is just 45 marks waiting to be totaled by you. So sketching the function. Now let's come here. Let's say we have y is equal to x plus 3. All right. And then we are asked to sketch that function. But before that one, let's look at this one. Y is equal to 2x. And there's a reason why I'm looking at y is equal to 2x on purpose, right? Now, you should note something. The gradient here is what, guys? What's the gradient for this function? Euclidean is also easy. It's very easy. Even that one, yes, it's worst grade 11 geometry. So easy. Okay, so gradient, yes, is 2. So it's positive. So already what we are expecting, we can already see the shape in our heads. Like in your head, the shape is already there. M is positive. It's an increasing function. So when I sketch, I know I'm going to be sketching something like this. C, the C value, your y-intercept, you can see most that there is no present y-intercept. So it must be 0. So since your C is 0, what are the coordinates of the y-intercept? Your coordinates for your y-intercept are what? They are 0, 0. Did you see this, Moss? They are 0, 0. Which means even if we used, because in grade 10, you guys did something called the dual intercept method. Do you guys still remember what the dual intercept method is? Okay. Dual intercept method. It's where you find the two intercepts, you know. You first find the y-intercept. Can you repeat, sir? Which part, Presh? Which part do you want me to repeat? Okay, so I said y is equal to 2x. This is the straight line function. It's in standard form. Then I asked, what's the gradient? You answered me. You said gradient is 2. Then I said, since it's positive, that means the gradient is positive. So what shape are we expecting? We are expecting an increasing function. So in our heads, we are already beginning with the end in mind because the gradient is positive. This is the shape we're expecting from our graph. No doubt, right? Because we learned that when the gradient is positive, the function is an increasing function like this. Then I asked, what's the C value, the y-intercept? Obviously here, the y-intercept, we don't have any constant value, so that means that the constant value is 0, right? So what is the coordinates of the y-intercept? That means it's 0, 0, right? I mean, remember, we just looked at how to find the coordinates of the y-intercept, okay? Now I am saying, if you remember from grade 10, whenever you sketched a straight line function, you used the dual intercept method, didn't you? You let x be equal to 0, you'd substitute. But I mean, for this function, if you let x be equal to 0 and you substitute, look what happens. You get y that is 0. So that means you get 0, 0 as your y-intercept. Then remember, you would also let y be equal to 0, which is basically how you find your x-intercept. And then you'd substitute in that equation, 0 is equal to 2x. Then you solve for x. But if you solve for x, right, you divide both sides by 2. Therefore, x is also equal to 0, which means the 0, 0. So you y-intercept method simply gives you the coordinates of the origin. That's not enough for you to be able to sketch your function. So what I want to then establish for you guys is that whenever you have a situation where you don't have a constant for a straight line, it is very key and important to come and use the table method from your calculator. And all you do is you just look at three important values for x. Three important values for x, all right? And those three important values for x are simply this. So for your x, all you need to check, and all you must then check, okay? Check the function on the negative side for x, one value. Check the function for one positive value for x on the other side. You already know when x is equal to 0, what is the situation? It's 0, 0. And all you do is use your calculator for that. Okay. I don't know if the network is good. Just let me know, guys, if the network does become a bit sinister. Okay. Just let me know if the network becomes a bit sinister, so that I can catch it very quickly and I can do something about it. If the network is okay, let me know in the comment section. If the network is bad, let me know in the comment section so that I can actually attend to it ASAP. I don't want us to miss out on valuable information here. All right. So I don't know if you guys know this. You can press mode on your calculator. You just press mode. Then you go there to Mr. Table. And there you have f of x. Something I didn't mention earlier on is that f of x is simply it's a notation that we use. And what f of x simply represents y. F of x stands for y. F of x is y. So sometimes instead of using y, we use f of x. I mean, we could use other letters as well. G of x, P of x, L of x, N of x. Basically, in other words, whatever of x you have, it simply just means y. That stands for y. Okay, so if we say f of x is equal to, remember my function was 2x. So all I do is I just press 2. Then I go to my red button there, alpha, and then alpha allows me to access all the red letters that I have on my calculator. So I want x there. There it is. F of x is equal to 2x. Then I press equally. Okay, then g of x appears. That's if I was having a second function, I would utilize g of x and I would write my other function in there so that I could have the table for that function, but I'm not going to use that. So I'm going to say equal. Where am I going to start? Let's start at -1 for x. So we start at -1. I press -1 and I say equal. Where do I end? I'm going to end at 1 because I just want to check the function there. It doesn't really, I don't really need much. Okay, so I end at 1. Then my steps, meaning in other words, as I move from -1, what is the steps? Meaning what is the difference between my values? So I want my difference between the values to be 1, because from -1 I want to move to 0, and from 0 I need to move to 1. So my step is 1. So I say step is 1, that's fine. I say equal, and there's my table. Look at this now. So when x is -1, f of x, which stands for y is -2. So y is -2. When x is +1, y is +2. Okay, so when I don't have a constant for my function, I must then use my table. And all I want, guys, is I just want to see the representation of the function on the negative side of my Cartesian plane, and I also want to see my function on the positive side of my Cartesian plane. So this is 0, this is -1, this is +1 for x. And then remember for y, I'm going to write 1, 2, 3. Let's just write that. -1, -2, -3. Okay, then I want to locate these points. So when x is -1, that's here, right? Where y is negative 2, that's there. Where do the two meet? Where do these two meet? They meet right there. That's where the marriage happens. -1 for x and -2 for y. There they are. All right. And then where do they meet? They meet right there. So that's our point. Then 0 and 0, that is the origin. I just want to mention, guys, that 0, 0 sometimes is termed as the origin. The origin. All right. So 0, 0 is there. Okay. And then last but not least, where x is 1, there it is. X is 1 is here. Where y is +2, that is there. Where do they meet? So horizontal, vertical, they meet right there. Okay. And all you do, guys, is you take your ruler. Okay. Everything should be pashash. Those two, they connect like that. Okay. Right? That's just like C. -1 and -2. That's so that we can see, guys. Okay, that's where we can see the points. Oh, the network is bad. Okay. Okay, let's try and do this then. The network bad. Okay. All right. I just Okay, just made some changes to my network and connectivity and connecting to something completely different. Is the network a little bit better, guys? Okay, I hope it is. I hope it is. If it's not, then I don't know. Okay. So yes, we use this approach when we actually don't have a constant. If we don't have a constant, we just select, please guys, we select one x value that's negative and one x value that's positive, so that we can be able to locate the points on either side. You see, the thing is, I chose one x value that's negative so that I can at least see what is the situation of my function on this side of the Cartesian plane. And then I chose one other x value that is positive so that I can see the situation on this side of the Cartesian plane. Then I could find the corresponding x and y value, the corresponding y value for each x value. So when x is -1, y is -2. There it is. When x is -1, y is -2, that's where these two meet. That's the point. When x is +1, y is +2. That is the location. And look at my straight line. My straight line is exactly what I expected at the end. Okay. Yes, let's say the thing is, in grade 9 you guys do this as well. So that's why it's giving grade 9 vibes, because we are actually going back to recap on grade 10 work, but this was also covered in grade 9, so that's why you might find that this is familiar to you. All right, very, very important. Yes, it will be on my YouTube. I'll be uploading this after I'm done with the session. So basically, this is the straight line. Okay, guys, I think the network is really fighting. It's fighting so bad. Okay, so this is how we sketch a function when we don't have when the constant is 0. When we use the dual intercept method, we simply get the origin. And the origin, in order to sketch the function, will not be enough. So that means we need to locate one x value that's negative, one x value that's positive, find the corresponding y value, and we simply use our table method in a calculator to be able to do that, so that it's easier to do. We don't have to, sort of like substitute and get the answers. We can just use our table method so that we can do this quick. Get the corresponding y value that's -2, get the corresponding y value when x is 1, that is +2, and then we locate the points, then we just sketch our straight line function. And do you see at the beginning we said when m is positive, when the gradient is positive, what did we expect? A straight line that is increasing. And there it is. This is the increasing straight line. We label the function y is equal to 2x. There it is. Okay. We have the x-intercept 0, 0. We have other points so that we can be able to see the function's shape. Okay, and please, when we connect these, just use a nice ruler so that no one can doubt what we've done. Okay, now let's look at this one. Y is equal to x plus 3. So this function, that straight line, unlike this one, has a constant that is not 0. So this one, we don't even have to use the calculator. Here we can straight up use the dual intercept method. And this is advised because it makes life very easy, the dual intercept method. What is the dual intercept method? The word dual means two, all right? It's like a fight between, or a battle between two people. So the x and the y are obviously opposites, and yeah, that's why we say dual intercept method, because we find the x-intercept first, or we can find the y-intercept first, doesn't really matter, and then vice versa. When we find the x-intercept, we let y be equal to 0. So we are going to come to this function, let y be equal to 0 in this function. So when we do that, 0 is equal to x plus 3. That means we solve for x. Remember, isolate x, we transpose the 3. So therefore, negative 3 is equal to x. Therefore, x is equal to negative 3. What are the coordinates? When x is negative 3, y we had let be 0. So therefore, negative 3 and 0 are our coordinates for the x-intercept. Then after that, we find the y-intercept. That's where we let x be equal to 0. And when we do that, guys, y is equal to 0 plus 3. Okay, then y is equal to 3. So that means y, guys, is 3 when x was what? Was 0. We need to be very careful here, because sometimes people mix this up. You know, someone says let x be equal to 0, and then they get a y value that is 3. Some reason or another, person writes 3 first and then they write the 0 last. So let's please make sure to be very deliberate. If you're finding the x-intercept, you've let y be 0, let it be clear that y was the one that we let be 0. Therefore, there the 0 is for who? For y. What did we find? X, which is what? Negative 3. There he is. In the place of x for sure, it's negative 3. Same thing when we are finding the y-intercept. We let x be 0 when we are finding the y-intercept. So we let x be equal to 0, which means we substitute 0 in the place of what? Of x. There it is. Plus 3 followed by plus 3, and then we solve for y. Y is equal to 3. So x is 0, y is 3. Now, since we have that now, all we simply do, we go and draw our Cartesian plane. And guys, we don't really have to label our Cartesian plane that much. All we need to do is we need to locate these 2 points, negative 3 and 0. Negative 3, where x is negative 3, where is that? Okay, negative 3 is here somewhere. Okay, and then where y, okay, is 3. Y is 3 is here somewhere. You see? Yeah, and therefore the connection is between those 2 points, and you can just extend it a bit further than those 2 points. So that is the x-intercept, that is the y-intercept. And basically you draw your function using the dual intercept method. Does it make sense that this function is an increasing function? Definitely, because what is the gradient or the coefficient of x? It is 1. What are we expecting the function to be like? We're expecting the function to be an increasing function. And of course, a straight line that is an increasing function. So therefore, this here, y is equal to x plus 3. This is truly the function that we are supposed to sketch. And it is 100% on point. And that is by using the dual intercept method. Okay. Okay. Then one last one. Okay, we sketched one where the constant was 0. We sketched one where the constant is not 0. Okay, and we just simply use the dual intercept method, which is straight up. And then let's sketch one more. Y is equal to negative 2 over 3x. Okay, sorry. Let me just redo that. Y is equal to negative 3x plus 1. Y is equal to negative 3x plus 1. Okay, so my question is to you, for this particular sketch, would we use the calculator or would we use the y-intercept method? What does the comment section jury say? Would we use the calculator for this or would we use the y-intercept method, and why? Calculator or y-intercept method, and why? Okay, Cecilia is amazing, and Azzy Boy is amazing as well. All right, you guys have a crack at it. Please go ahead, sketch this for me. You guys have your I'm sure you guys have everything before you. I'll give you a few minutes just to sketch this function for me quickly. All right, sketch this function. After you're done, sketch this one, and after you are done that one, sketch this one. And then to really show me that all is well and all is good and that you really get it so well, you are going to sketch this one. So you can sketch these for me. Okay, sketch these 1, 2, 3, 4 for me. Okay, I wanna see if you guys can do that for me. Can you just do that for me? 1, 2, 3, 4. All right, I'm gonna give you 5 minutes to sketch all 4. How's about that? 5 minutes. I'm glad you do, Rob Reed. I'm glad you do, no doubt. I'm glad when you know all the answers. Go ahead and do it, you know. Maths is best learned when people do. Maths is not best learned when people listen and they just observe. It's best learned when they do. And when a person is able to do, that's when you know that they've got it, like seriously. Okay, so if you guys can sketch these 1, 2, 3, 4 functions for me, me will be very happy. We'll be very happy. Okay, so at 8:15, I will then jump in and actually do the sketch for all of us. But for now, I want you guys to also just go ahead and spend some time, draw these functions 1, 2, 3, 4. Please, I'd really appreciate that if you can. So let me give you some time. I know some of you will gravitate away from the live because, like I said, it's a matter of you wanting to just listen to what I'm saying, but it would be good if you can actually spend some time and do it yourself as well. Rob Reed, I know all the answers. Funny guy. There we go, Boy Dumel. I have no idea, Boy Dumel, when I'll be doing a hyperbola function. Guess I'll do it when I'm content that all the other functions are sorted. But after straight line, I'm gonna do parabola, and then after parabola, I'll do hyperbola, and then after hyperbola, exponential. So. But remember, we need to get the basics. We need to get these ones okay first. Because remember, you guys have done straight line in grade 9. You did it again in grade 10. So I'm just trying to make sure that whatever you say you claim to have done, it's still really and truly something that you know and you can do well even now. So that when I do move on to the other functions and we explore them for what they are in grade 11, we can be all good. We'll be good. Rob Reed. Rob Reed. We're not fighting you, don't worry, my elite, we're not fighting you. Okay, so we've got 1 more minute to sort of like wrap up whatever it is we are doing with regards to answering the question. Glenn Grill, Sus Boys, T0909, Sbuda to Buddha, Zolis from Bambi, all these people that are coming in, P-Boy Wanda, Sander 20054, Theoza, Shashalaza, Dominique. Mobile. Wow, Kevin. Long time, pretty boy. Okay. All right. Time is up. Okay. All right. So hopefully we are all good that here we are definitely going to use the dual intercept method, aren't we? Very nicely so. And I just use the dual intercept method, no problem. You know, just use dual intercept method. Just use dual intercept method. So if we use dual intercept method here, we are going to let x be equal to 0, right? When we let x be equal to 0, y is equal to -3, 0 plus 1. So y is equal to 0 plus 1, y is equal to 1. So that means our coordinates for the y-intercept are 0 and 1. After letting x be equal to 0, we let y be equal to 0. So 0 is equal to -3x plus 1. Okay, you see what's nice here now is that we are applying the algebra that we learned in term 1 and all the algebra that we've learned. Okay, so some of you, obviously, if you're gonna be confused, maybe let's say for instance you find that, yo sir, what did you do there? Okay, that has to do with the fact that there has been no mastery of those concepts yet. Okay, so the whole of term 1 they spent with solve for x, solve for this, solve for that, and you were doing that for that duration of time so that you could master that part, so that when you do functions it's no longer an issue, you see. So yeah, so here we divide both sides by -3, we get x is equal to +1/3. All right, so that means our x-intercept is 1/3 and 0. Okay, then when we sketch the function, guys, dual intercept method is nice like this. We just locate 0 and 1. We know 0 and 1 is here somewhere. Okay, that's where y is 1. Okay, but on the on the y-intercept. Then here 1/3 and 0. Remember 1/3, if you put in your calculator, you get 0.333333. So that is actually between 0 and 1, but closer to 0, 0.3. Okay, so you just write there 1/3. Okay, and look at the shape, look at the coefficient of x, it's negative. So what are we expecting? Expecting a shape that is like that. Okay, so and indeed, look at this. You see, man. Okay, I label 1/3 so that people know that, okay, that's the point, and I label that one as well. You see, yeah, and then I label the graph. Y is equal to -3x plus 1. I hope you guys did it as beautifully as I did it. and that you're proud of yourself and your dual intercept method skills. You are phenomenal. Okay, I want to come here now to number 2. X is equal to 3. Remember, this is the equation where the subject is x and we have a constant that is 3. Okay, so all we do is we go to our Cartesian plane, we go and locate the value 3. What do we know and understand? If you remember, when I explained the theory at the beginning, I said that when m, very good Cecilia, I'm proud of you. When m is undefined, that means we have a vertical straight line, all right? It's perpendicular to the x-axis. So basically the equation is usually given, the standard general form for a vertical straight line where m, where the gradient is undefined, is x is equal to some constant value. So in the same vein, I know what the shape of the function will be. X is equal to c. And some of you may be like, but sir, didn't you say that the general form for a straight line is y is equal to something? Look guys, the only reason why this is the case is because the gradient, meaning the coefficient of m, is something that is not defined. It's undefined. And therefore, because it's undefined, we say that the equation for that vertical straight line is x is equal to c. All right. So this here, x is equal to 3, is a typical example of a. So x is equal to 3, the value 3 is here. But understand that x is equal to 3, x is equal to 3 everywhere on this vertical line. Remember, x is equal to 3 is not just on the x-axis. X is equal to 3 is everywhere on this vertical straight line, everywhere. X is equal to 3 here, x is equal to 3 there, x is equal to 3 here. Are you with me? X is equal to 3 everywhere on this vertical line. So when you draw your graph, this is your graph. So you say x is equal to 3. Please guys, please understand, when you draw the graph x equal to 3, this is your vertical straight line. This is your graph. Okay. How many people actually were able to draw the correct graph for x is equal to 3? Indicate in the comment section, but be honest, because and remember, the angels are watching you, so don't lie. Right? So yes, x is equal to 3. This is it, but this is it. Vertical straight line. A vertical straight line. This is where the gradient is undefined. Okay? Crash with that hand that is raised to the square. Before a Supreme Court judge, you raise your hand and you swear that you actually did not, in actual fact, lie to me and say something that you're not supposed to have said. Okay, so if you guys got that right, that's 100% fine. If you didn't, at least you've learned something. Okay, remember, this is not a test, this is still you learning. But if you did not know, now I'm telling you, this form x is equal to c is for every vertical straight line that you'll get when m is undefined. You know that the gradient is undefined for a vertical straight line. For m is equal to 0 and the gradient is equal to 0, the equation or the form is y is equal to c. So it's a horizontal straight line. So look at this function, y is equal to -7. That simply means we draw our Cartesian plane. We go and locate -7. Okay. And everywhere on this horizontal line, y is equal to -7. So this, okay, please guys, straight line with a ruler, of course. Okay, I'm drawing freehand because with the one hand I'm holding something. So please understand that you would have to take your ruler, you draw that horizontal straight line. This is the equation y. This is the function y is equal to -7. You can see it visually. This is the algebraic representation of the function. This is the visual graphical representation of the function. Y is equal to -7, a horizontal straight line. This is where the gradient is equal to 0. This is where the gradient is undefined. This is where the gradient is equal to 0. This is where the gradient is undefined. Please people, very important, these things. Okay, right. Okay, who got this one correct? And hopefully we all did, hopefully. But if we didn't, like I said, learning curve. opportunity to learn, opportunity to make sure that we get it for next time and next time and next time. Very, very important to never, have mishaps in the future. Okay, all right. Okay, then last but not least, y is equal to 3x minus 1. That straight line, y is equal to 3x minus 1. So once again here, our constant value is not 0. So we use what? Calculator, table method, or do we use our dual intercept method? Which one? Dual intercept method, calculator. Dual intercept method or calculator. Okay, hopefully guys, now we can distinguish in our heads that, okay, in this situation we use a calculator, in this case situation dual intercept method, because when we know that, then it helps us a lot, right? When we can distinguish when we need to use the calculator and when we need to use the dual intercept method. And already you can see that the gradient, okay, yes, dual intercept method indeed, the gradient here is positive. So already you are expecting, all right, that our straight line m is equal to 3, m is greater than 0, we are expecting our function to be an increasing straight line of this nature. Then all we are left to do now is just find the y-intercept. We let y be equal to 0. 0 is equal to 3x minus 1. We transpose the 1. And therefore x is equal to 1 over 3. Okay. Then we let x be equal to 0. Y is equal to 3 into 0 minus 1. We get y is equal to negative 1. So that's basically 0 and negative 1, whereas this one is 1 over 3 and 0. Now we are ready to sketch, guys. We are ready to sketch. So let us open up some space. We've got our y-axis here, we've got our x. Okay, then remember we had 0 and negative 1. 0 and negative 1 is here, down here somewhere. So, and then 1 over 3 and 0. 1 over 3 and 0. Remember 1 over 3 and 0, that's basically between 0 and 1, but 1 over 3 is closer to 0. So let's write 1 over 3 there. Then we just point here, point there. Then we connect. Okay, when you would use a nice ruler, please, not freehand like me. You use a nice ruler, connect the dots. Make sure that 1 over 3 is very evident so that your teacher can see, oh, he did see that x-intercept is 1 over 3. And then that negative 1 as well, very clear for your teacher. Then you label your function y is equal to 3x minus y. All right, and I'd already set it up because when m is equal to 3, I know the shape of the function, how it should look like. You see, so it's like there's no ways that I can ever get the function incorrect. No ways, Jose. No ways. No ways. I'd never not sketch the function correctly. If it's a straight line, never, ever. Ever, never. You know? Yeah. All right. Any questions, good people? Yeah, my network, I say, my network is kind of somewhat failing me, hey? I can see that the numbers are going up and down. It's like, is it that bad? Let's see. Who's constantly here? I see Comfort. How's the network? My regulars, people that are here. Is there a very huge lag? Is it slow? Is it not harmonious? Is it making you sad? Presh is saying it's okay. Okay, Presh, you give me hope. Give me hope, Joanna. Oh, it's not bad. Okay, but it is bad, but it's not bad. Okay, that's fine. That's fine. Okay, no, that's fine. Titeboho is like, he can't wait for this live to end. It's like, it's dragging. Okay. Since we are still in straight line functions, I wanted to check something. Gradient. Can someone tell me about the gradient for lines that are parallel? What do we know? Parallel lines, parallel lines, parallel lines. it's gonna end at 9. I'll end at 9. Okay, Presh. So parallel lines have the same gradient. I like that. Equal gradient. Equal and same. Okay, so we used equal and we used same. All right. So parallel lines have equal gradients. Right? Very nice. Very nice. So in other words, M1 is equal to M2 for what? For parallel lines. For parallel lines. Okay, let's put those arrows that they usually put to indicate parallel lines. So parallel lines, we have equal gradients. Right, then perpendicular lines. What about perpendicular lines, guys? Perpendicular lines. What about perpendicular lines, guys? What about perpendicular? What do we know about perpendicular lines? Perpendicular lines. Okay, I need to see the full conclusion about perpendicular lines. Perpendicular lines, they meet at 90 degrees. Oh, look at that. Perpendicular lines, they meet at 90 degrees. Ooh, yeah, that's true. So therefore, you need to tell me something about their gradients. I like that. I like the fact that you're saying the perpendicular lines, the lines meet at 90 degrees. So that's basically it. You can see this here. 90 degrees perpendicular, angle 90. No, Nenweli, no, the gradient is 1. No. So if this is line 1, the vertical line is line 1, and then the horizontal line is line 2, what do we know about their gradients? The gradient of line 1 times the gradient of line 2 is equal to -1. So in other words, the product of the gradients is equal to -1. So that's why I like there's a reps. There's sort of like a rep that I came up with parallel lines, and it's like parallel lines equal gradients, parallel lines equal gradients, parallel lines equal gradients, parallel lines equal gradients, perpendicular lines, the product of gradients equals to -1, the product of gradients equals to -1, the product of gradients equals to -1. So parallel lines equal gradients, eh? So parallel lines equal gradients, parallel lines equal gradients, parallel lines equal gradients, perpendicular lines, the product of gradients equals to -1, the product of gradients equals to -1, the product of gradients equals to -1, the product of gradients equals to -1. So yeah, you need to remember that parallel lines have equal gradients, but perpendicular lines, the product of the gradients is equal to -1. If you know that, Speedo, all is well, Speedo. So y is equal to 2x plus 1. Let's say f of x is equal to 2x plus 1. If g of x is parallel to f of x and passes through so f of x is equal to 2x plus 1 if g of x is parallel to f of x and passes through 3 and 5. What is the equation of g of x? Okay. Should do a collaboration one day. Oh man, that would be funny. If ever that would be the coins. I don't even know the guy. Yeah, I've just seen the guy obviously on like platforms and stuff, but yeah. So f of x is equal to 2x plus 1. If g of x is parallel to f of x and passes through 3 and 5, what is the equation of g of x? That is the question. Alright? So if f of x is equal to 2x plus 1, f of x is equal to 2x plus 1, if g of x is parallel to f of x and passes through 3 and 5, what is the equation of g of x? So this is where we actually have to find the equation of this particular function, but that's given the fact that the lines are parallel. All right, f of x is parallel to g of x. Okay, so remember here we know that f of x is equal to 2x plus 1. We know that g of x is parallel to what? To f of x. So if that is the case, guys, if that is the case, first and foremost, we know g of x is equal to mx plus c. Now, all we want to find is the gradient of the function and the y-intercept. So, let's first check here. What is the gradient of g of x? If g of x is parallel to f of x, what is the gradient of g of x? Because we need m and we need c. So we want m, which is the gradient. We know f of x is 2x plus 1. What is the gradient of g of x? So Kaugelo says 2. So does Cecilia and Nenweli. So it's like most of you are actually saying it is indeed 2. And you know what? I agree. So we can say that the gradient is 2. Why? Because we know that for parallel lines, the gradients are equal. So therefore, y is equal to 2x plus c. Now, all that we are short of now is to find the value of c. But there's some information we got, and that is g of x, since it's parallel to f of x, it also passes through 3 and 5. Okay, so that means we are going to use our point 3 and 5. All right, use that point 3 and 5 so that we can get the value of c. So we are going to substitute in function. So let's do that. X is equal to 3, y is equal to 5. So where y is, we substitute 5. Where x is, we substitute 3. Okay? And then we go ahead and we solve for c. Take the 2 times 3, we get a 6. Therefore, we take the 6, we cross it over, we get 5 minus 6 c is equal to -1. So therefore, what is the function? Remember, we were told to find the equation of g of x. So g of x is equal to, what was our m value? It was 2. What was our c value? It is -1. Right? And guys, this is basically how we are able to apply our knowledge of knowing that parallel lines have equal gradients. When we know that the lines are parallel, it means if one function that is a straight line is supposedly parallel to the other, then that would therefore infer that the gradients are the same. Are you with me? So if the gradients are the same, then it means then we can compute, or we can attribute the same gradient of f onto g, so that we can have the gradient for g, since f of x and g are parallel. So that's why we said y is equal to 2x plus c, because the gradients of the two functions are the same. Then we use the point that the line or the function that we are finding passes through, to then be able to get the value of c by substituting that point onto that same function that is populated with 2 as the gradient. We substitute in the place of y and x, y which is 5, x which is 3. We then manipulate and we simplify. 2 times 3 is 6. We transpose. Guys, you see, all of these skills of algebra are being put to use, and how important it is for then you to be accurate, because you showed absolute accuracy and supremacy when you did term 1. So it must show when you do functions that when you're not something to play with, you're not a plaything. Okay, I want to do one last question, one that has to do with perpendicular lines. I'm going to these questions, guys, are literally being created as you see me in the live, you know. I'm creating the questions as I go along, but these are also in line with some of the questions that I've seen being asked. So h of x is equal to 3x minus 1. If g of x, which is equal to mx plus c, is perpendicular to h and passes through -2 and 4, find the function g. So h of x is equal to 3x minus 1, right? This is what we are given. Now we are told if g of x is equal to mx plus c is perpendicular to h and passes through -2 and 4, find the function of g. So, how do you suggest we proceed? Any bright ideas, my beautiful, amazing people, in the comment section? H of x is equal to 3x minus 1. If g of x is equal to mx plus c, so our functions h and g are obviously what type of functions, both of them? Because we can see the form. What type of functions are these functions, both of them? They are both linear functions, right? Now we are asked if g of x is equal to mx plus c is perpendicular to h. Now that important word, perpendicular, what does it suggest? What then do we know? If h of x is equal to 3x minus 1, what do we know about the gradient of g? So this is the gradient of h times the gradient of g should give us what? -1. Why? Because the lines are perpendicular, right? That's why. So the gradient of h times the gradient of g should give us -1. What's the gradient of h? It's 3. What's the gradient of g? That's what we want to find. Equal to -1. What's the relationship of 3 and the gradient of g? It's multiply. So how do we get rid of 3? We divide both sides by 3. So what is the gradient of g? It is equal to -1/3. That is the gradient of g, because for perpendicular lines, the product of the gradients is equal to -1 for perpendicular lines. So I use that knowledge. All right. Now, some people may find it easier to not even do this algebraic manipulation. Some people may find it easier to just simply say, if the stands to reason that flip the fraction, so 3/1 becomes 1/3, and then they change the sign. Flip the fraction, 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 change the sign. So yeah, guys, you flip the fraction, you change the sign. So you flip the fraction, you change the sign, right? So if you doing this is also fine. If you simply just write the gradient of g instead of working it out, it's 100% correct to go ahead and do that. Remember, the reason why you say the gradient of g is flip the fraction, change the sign, is because you know that the product of gradients equals to -1. The product of gradients equals to -1. So what do? You flip the fraction, change the sign. So you do that, guys, and then the gradient is there. So the gradient is -1/3. The gradient is -1/3. When you multiply these two together, you get the product, the outcome, which is -1, which works out nicely, guys. No problemo. So I wanted the equation of g. So g of x is equal to, I've got the gradient, so I have -1/3. Oh, pressure. Come on. No, man, don't kill me here. Boca Studio. That's the best comment. That is actually the best comment. Actually, that is probably up there today with the comments that I've gotten that kind of crack me up. The Kevin Maths and Science one kills me, but together with that, in conjunction with that, is Boca Studio. That is fire. Okay, -1/3x plus c. Then what do? You take a point, that -2 and 4. We just go ahead and we substitute it, guys. We know that this is x, this is y. G of x we know stands for y, and then the x is -2. Then we solve, guys. We just solve. And the thing is, we are masters at solving for unknowns. At this stage, we are masters, guys. Please, man, please. We can't disappoint the nation now. We are masters. We are masters at solving for unknowns. Just grab the calculator, you punch it into the calculator, you get 10/3, no problem. 10/3, no problems. Okay. And then you conclude, therefore, g of x is equal to -1/3x plus 10/3. Bravo. Comprendo. All right? Bravo, bravo, bravo. Magnifique. Magnifique. Right? All right, guys. that is basically what I wanted to cover today as far as the straight line function is concerned. Now, of course, there is more to the straight line function, but I don't want us to be overloaded. I'm going to do pieces and fragments at a time, so that at the end of the day we can get all that there needs to be gotten. All right, so for now I will hold it right here with our straight line function. Okay, yeah, and then I'm going to pick it up the next time. If you want to know when is the next time, guys, I don't know yet, but I will definitely let you know when the next time is. So what I will do is I'll actually upload this onto the YouTube channel for those that probably were like, yay, the network was doing funky stuff and all of that stuff. And then, yeah, we'll take it from there. We will delve into this world until we have delved into every corner, nook and cranny. Please do make it a point, if you want to go and check out the full depth of the function. Yes, tomorrow, Pressure, I'll definitely have a session with you guys tomorrow, definitely. But like I said, I'll let you in on the time and stuff. It's just that the day, you know how it is. Most likely will be probably 9. I'm sorry, I know it's kind of a school night still, people are still having to prepare for the next morning and what have you, but it may only be the available time, or it might just be at 7. All right, so I'll definitely let you know. I'll bank on 7, but yeah, I'll try my best to make it 7. Okay, it seems like it's a good time, 7. But thank you so much for joining in. I really appreciated it. Also, if you guys have questions, okay, please do make it a point to ask your questions if you have any questions. I'm all up for actually also having people become guests and stuff like that. We can chat. We can chat with your questions, if you know what I mean. We can entertain those questions in that format if you want to. Like I said, just let me in on anything that you'd like clarity on. Okay, are we good? Can we call it a sweet night? As your manager, we are recording tomorrow. You're a talent. Brash, don't kill me here. As your manager, my goodness, I need a manager. Man, I need moderators. Now that you say that, actually, I need moderators on my live sessions. Actually, yeah, we're recording. Eh? Yeah, if only you had recorded actually when I was doing the thing, when I was doing it, then maybe you could have had a repost here. Give some people a taste of how things can be. But thank you so much, guys. Thank you, Luandle. Thank you. Yeah, and then also towards the end of the week, guys, we are having a planned celebration of Mark's thing happening as well. I think we have to do a live session where we can actually just have guests on end, and we can just like have people share how the term was, the previous term at least, and like results, how things came out, like, happy results that we are happy about, and we can share if we want to and stuff. I think that would be awesome. But yeah, thank you again. We will see each other at another time, in another live, in another time. Goodbye. Yeah, that's what we want to celebrate. Bless Mal. We'll do that, like I said, towards the end of the week. Definitely we need to have a session for that, because I'd like to get overalls, and yeah, percentages. We can celebrate all of that and stuff like that. Maybe share experiences that we had and all of that stuff. Kind of envisioning all of that stuff happening. Celebrate marks, celebrate results. Get us amped up for term 2, guys. Yeah, we can't stop doing the things that we know they work. Need to continue doing those things. Okay, so what you must do to master surds? What must you do to master surds? To master surds, you must just go ahead and do the surds, man. Learn the surds first and then do them. Learn the surds and do them. Learn, understand the concept of surds and then do them. That's it. Like there's no magic formula. Know the basics, very true. Know the basics of science. Yeah. I don't know how else to put it. Let me end this live. If you want, I'll come back on